Here we're going to look at question 4 from section 2 of the ENGAA specimen paper. So in this question, we're told that we have a mass of 5 kilograms, which is being pushed up a rough slope, a height of 3 meters. We're told that the frictional force acts against this mass, which we labelled here as F, and that the slope is angled at an incline, or an angle of alpha, with tan alpha being equal to 3/4. So then we're also told that this object, this mass, loses 210 joules of kinetic energy on its path from P up to Q, the top of the slope. The question then asks us to find this frictional force F. If you would like to have a go at this question yourself, then please pause the video now, otherwise let's have a go at it. Okay, so to think about trying to solve this question, let's have a bit of a think about which equations we could use and how we might arrive at our answer. So we've been told about some energy, and we know that we have a force, a frictional force acting on this rough surface. So what about an equation which is going to relate energy to a force? Now, probably the easiest one you can think of is going to be this one. That work is done by friction, or the work done by friction, is equal to the force, the magnitude of our frictional force, multiplied by the distance the force acts along. So this distance is going to be the distance from P up to Q here on our diagram. So if we can find this distance d, and we can work out the work done by moving our mass up to Q, then we can find our frictional force. So let's have a bit of a think and see if we can come to our value of d first. So we know that tan alpha is equal to 3/4. So what does tan alpha actually mean? Well, it means that the opposite of our triangle, tan alpha is equal to the opposite of our triangle divided by the adjacent of our triangle. So this side here, our 3 meters, divided by this unknown side, gives us our 3/4. And now, since we know that this side is 3 meters, for this to be true, then our adjacent side at the bottom of our triangle, its base, has to be 4 meters. And now with this information, we have a right angled triangle with 2 of the sides. So we can use some Pythagoras to try and find d. So simply solving this, we get that d equals 5 meters. So with this information, now we can try and think about the work done by our force, and then we can work out the magnitude F itself. So to think about the work done by our force, we can try and think about where this kinetic energy goes. So the kinetic energy of our ball is going to decrease as it increases due to the frictional force. So obviously some of the work done is going to be by friction, but not all of the energy is going to be lost by friction. A portion of it is going to be lost or converted into gravitational potential energy because the height of the mass is increasing. So if we can work out what this portion is going to be, then we can definitely find out what the work done by friction is going to be. So to try and find the increase in GPE from P going up to Q, our equation for gravitational potential energy is just the mass multiplied by the gravitational field strength multiplied by the height. So we know our mass is a mass of 5 kilograms. We know that G is just 10. We know the height it travels between P and Q is 3 meters. So multiplying these together, we get that the gravitational potential energy is going to be 150 joules. Therefore, that means that since we have 210 joules being lost of kinetic energy, with 150 joules of that being converted into gravitational potential, the work done by friction has to be 60 joules. So now, when we look at our original equation, we know that the work done by friction is going to be 60 joules, and we know that the distance is going to be 5 meters. So we can rearrange this equation to get that the frictional force is equal to the work done by friction divided by the distance acted along, and then we can substitute in our value of the work done, which is 60 joules, and our d equals 5 meters. To get this, which of course just divides simply to give us that the frictional force has a magnitude of 12 newtons. So this is my final answer and corresponds to answer A given the question.